And now it's time to play Who's That Particular Solution? Woo! And in particular, no pun intended, guess the form of the particular solution to y double prime minus 4y prime plus 13y equals e to the 2t. And before you do any guessing, you have to check for resonance. And in order to do that, let's find the roots of the auxiliary equation. So r squared minus 4r plus 13 equals 0. Feel free to use a quadratic formula, or here I think it's easier to complete the square. So r minus, or r plus half of minus 4, so r minus 2 squared minus the square of that. So minus 2 squared is 4, and then plus 13 equals 0. So r minus 2 squared plus 9 equals 0. So r minus 2 is plus or minus 9. So plus or minus root of minus 9. So r minus 2 is plus minus 3i. So r equals 2 plus minus 3i. And now let's look at the right-hand side, which is e to the 2t. And ask yourself, what root would give you ae to the 2t? So e to the 2t, well, it would be r equals 2. And again, important, if it coincides with the homogeneous root, it has to coincide exactly. So because this 2 is not 2 plus minus 3i, we say it does not coincide. So it does not coincide. Coincide. And so there is no resonance, and so we guess just the usual thing. So we have the right-hand side e to the 2t. So by rule 1 of undetermined coefficients, you guess ae to the 2t. All right, let's continue. Let's do y double prime minus 4y prime plus 13y equals cosine of 3t. Again, no need to reinvent the wheel. The homogeneous roots are 2 plus minus 3i. So now the right-hand side is cosine of 3t. Again, backtrack. What root would give you cosine 3t as a homogeneous solution? It would be r is plus minus 3i, which once again, it does not coincide. Not coincide. So no resonance. And then I think you just apply rule 3 of undetermined coefficients, which says whatever goes with cosine, repeat with sine. So a cosine 3t plus b sine of 3t. And now you may have guessed it. Let's do y double prime minus 4y prime plus 13y is e to the 2t sine of 3t. Now the right-hand side is e to the 2t sine of 3t, which gives us the root 2 plus minus 3i. So 2 because of the exponential term, plus minus 3i because of the sine term. And now, if we compare, it does coincide. So ding, 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 you won the resonance jackpot. Which I don't think is a very good thing. So coincides, and so we have resonance. And what does resonance mean? You add an extra t. So usually you would have guessed A e to the 2t cosine 3t plus B e to the 2t sine of 3t. But because of resonance, we add this extra t. All right, so just two more examples of this. Again, same equation. And let's do y double prime minus 4y prime plus 13y is, let's say, t squared cosine of 3t. So here, the right-hand side, just look at the cosine 3t term. So the t squared, t, they're all polynomial. Most of the time, they don't matter. So look at cosine 3t. The only time it matters if it is a zero root, but that's a different story. So cosine 3t, that would coincide, that would correspond to the root plus minus 3i, which does not coincide. Coincide. And so what we get, so remember, whatever happens with cosine, you repeat with sine. So definitely there's a cosine 3t and then a sine of 3t. What do we do with the t squared term? T squared has degree 2. So you guess at squared plus bt plus c. And then because we have cosine, we repeat this with sine, and you get dt squared. Dt squared plus et plus f, and then sine of 3t. Let me repeat. So because you have cosine, you repeat everything with sine. T squared has degree 2, so you replace it with at squared plus bt plus c, and so you're repeating that, you do dt squared plus et plus f. Now, last but not least, look at y double prime minus 4y prime plus 13y equals a t to the 2t, a sine of 3t. And again, for the right-hand side, just look at the exponential and sine terms. So e to the 2t, sine of 3t, that corresponds to r is 2 plus minus 3i. Now it coincides. So remember, because it coincides, we have resonance. So we have to add an extra t. Now let's see what we do. So this t has degree 1. So you replace it by at plus b. Plus b. E to the 2t. And again, whatever happens with sine, you do it with cosine. 3t. And then same thing, ct plus d. E to the 2t. Sine of 3t. And because there is resonance, you have to add an extra t. So the answer is t times at plus b times e to the 2t cosine 3t, and the same thing with sine of 3t. And you just won, who's that particular solution?